Hello student, today I am going to explain chapter 3 metals and non-metals part 8. Conversion of enriched ore into oxide of metals. I have given first example in the previous segment. Now we take second example. Carbonate ores. Carbonate ores are also calcined to expel carbon dioxide. For example, calcium carbonate. When calcium, it gives calcium oxide and carbon dioxide expelled out. In the calcium magnesium carbonate, calcium oxide and magnesium oxide are to get separated and carbon dioxide is expelled out. Another example, zinc carbonate gives zinc oxide and carbon dioxide is expelled out. In the basic copper carbonate ore, copper oxide is removed and water and carbon dioxide is expelled out from this, and that is why we can get oxide of metals by carbonate ores by using the process of calcination. This process is used in calcination, but the sulfide ores here are generally get separated by roasting. For example, sulfide ores are usually converted to oxides by roasting. The process involves heating the ore a temperature below its fusion point or melting point, but always in the presence of air, so that it may be oxidized. For example, zinc blende is roasted in air to convert it into zinc oxide. Like this, zinc sulfide when reacted with air, it gives zinc oxide and sulfur dioxide is expelled out. In another example, galena, ore of lead, M.P.S, is converted into lithium or lead oxide by roasting. When lead sulfide is reacted with oxygen, lead oxide is get separated and sulfur dioxide is expelled out. So we can use calcination or roasting process for the carbonate ores and sulfide ores. So what is the difference between these two processes? So we can conclude points of difference between calcination and roasting. Calcination, the ore is heated in the absence of air, but in roasting the ore is heated in the presence of air. In the calcination, oxide or carbonate ore are used. Oxide or carbonate ores are used, but in roasting, sulfide ores are used. So there is 2 points of difference between calcination and roasting. Calcination is done in the absence of air, but roasting is done in the presence of air. Calcination is used for oxide and carbonate ores, while roasting is used for sulfide ores. Now we can extract metals from metallic oxide. What are the extraction process of metals from metallic oxide? A metal oxide produced is reduced into metal. For this, the method used depends upon the reactivity of the metal being extracted. First, reduction by heat alone. Metals occupying lower position in the reactivity series can be obtained by heating their oxides. For example, lead sulfide get converted into lead oxides and sulfur dioxide is released. After that, these lead oxide, mercuric oxide get converted into mercury and oxygen is released. Second, chemical reduction. Metals in the middle of the reactivity series like iron, zinc, nickel, stannum cannot be obtained by heating their compounds. So they require to be heated with a reducing agent. Usually carbon or coke. When a metal oxide is heated with carbon, it is reduced into free metal. Metal oxide reacted with a carbon or coke gives metal and carbon monoxide. Here M represent metal. This reduction is known as smelting. For example, when zinc oxide is heated with carbon, zinc metal is obtained. In this way. Zinc oxide reacted with coke gives zinc and carbon monoxide is released. Another example, ferric oxide Fe2O3 is reduced to iron by heating with coke in the blast furnace. That is a very special furnace that are used especially for iron ores. Ferric oxide when heated with coke gives iron and carbon monoxide is also released in this process. So in the middle of the reactivity stage we can separate the metallic oxide by using some chemicals like carbon, but all ores that are in middle of the reactivity stage are not obtained by using coke. So we use aluminium as a reducing agent for these metallic oxides. So reduction with aluminium. This process is also known as thermit process or aluminothermic process. So now we explain some metal oxides cannot be reduced satisfactorily by carbon. For them, aluminium, a more reactive metal, is used. This process is called thermit process or aluminothermic process. For example, manganese dioxide is reduced to manganese by heating with aluminium. For example, manganese dioxide reacted with aluminium gives manganese and alumina is separated. In this way, we can separate a suitable metal by using aluminium in the middle of the reactivity stage. Now we can take another segment. Another example of thermite process is ferric oxide is reduced by aluminium to free iron. Ferric oxide when reacted with aluminium gives iron and alumina is separated. Some metals are very reactive and that are in the top position or bottom position or higher position in the reactivity series. Such metals are get separated by electrolytic reduction. Such metals are separated by electrolytic reduction. The reactive metals like sodium, potassium, lithium that are high up in the reactivity series cannot be produced by any of the above methods. So they are obtained by electrolytic reduction of their molten oxides or chlorides. During electrolysis, the cathode supplies electrons to metal ions for their reduction to the metal. For example, sodium metal is obtained by electrolysis of molten sodium chloride. Molten sodium chloride when supplied electricity, it get depleted and split up into sodium ion and chloride ion. Chloride ion accept the electrons given by sodium ion and they form chlorine gas. And these electrons, when accepted by sodium ion, it gets separated on cathode, and at cathode it gives metals. So overall reaction for electrolysis of sodium chloride, pure sodium chloride is NaCl gives Na plus Cl2. That means sodium is separated at cathode and chlorine gas is released at anode. And this process is mainly for highly reactive metals. And during the electrolytic reduction of molten salt, the metals are always obtained at the cathode. So now I will discuss the next segment of refining of metal in next class. Thank you.